everyone, and welcome back to my YouTube channel. Today we are starting with our first video for the newly launched module, that is Python for data science. So in this video, we will have a look at what is Numpy. We will get to know a few basics about Numpy library, and we will see how the Numpy arrays are created. To start with, what is NumPy? NumPy stands for Numerical Python, and it's a library for Python which adds support for multidimensional arrays and matrices along with large collection of high-level mathematical functions to operate on these arrays. So this is formal definition of NumPy. However, I would like to give you a background of what prompted this NumPy library to be there in Python. Look, C has a concept of an array, okay, and NumPy has got Python has got lists, that is Python lists. Okay, now as Python is not that fast as C, what was decided that maybe we can use the speed of C and the data structure of Python, and why not combine them together? And that's where NumPy came in. This library is made in C and Fortran, and we are just using it in Python. So let's first see what is the difference between Python list and NumPy arrays. Okay, so it's an array. It will store homogeneous kind of data type. For NumPy array, it stores homogeneous a data type, that is all the elements in that array will be of same data type. And NumPy is specially used for, most of the times it will be used for numerical analysis, so you will find out the data types most of the times as numbers. Okay, and in Python list, you can store heterogeneous data types. You might have seen our course for Python beginners where I have talked about list. Then performance wise, NumPy is much faster. However, Python list, when they are exposed to large data sets, performance dips down. All right. Memory wise as well, NumPy arrays are more efficient as the way what you can say elements are stored in a contiguous manner. And in Python list, the memory may be the elements in the memory could be stored in scattered locations. All right, and if you say functionality wise, then NumPy arrays have a lot of mathematical functions involved, and in Python list there are limited built-in operations. So that's about the difference of NumPy arrays and Python list. We will also see how efficient it is time wise when we do this coding exercise, while we create new NumPy arrays. Now in NumPy arrays, there is only one data type, that is ND array object. ND array means n-dimensional array. Okay, it's a core part of NumPy, and let's see how we can create those arrays. So before creating those arrays, I would just like to tell you that NumPy doesn't come installed with Python. You have to install it separately. It's a different library. You will have to install it separately. Say in some platforms like Anaconda, it may come installed already. However, if you are doing code on your machine using some IDE, you might have to install NumPy. And to install NumPy, this is the command we already know. Okay, pip install. Now, um, after installing, you will have to import that NumPy, and you'll have to also specify an alias name, though not a compulsion. However, when you will be using this word NumPy, or you will be using NumPy while you code, right? So you don't want to use this big word. Instead, you just give an alias name, and use that alias name while you create some array objects or do any NumPy operations. All right, so let's see how you can create a one-dimensional array in NumPy. So I've taken a variable arr, and in that np dot array is the function that I'm using, and I'm passing a list into that. This will create an array for me, one-dimensional array. So I would just run this cell. You would see array being created, and it will show it to you as a array object. Let this run, and we will see the output soon. All right, it gives me an error because I did not run the first cell. I have to import the NumPy library. Now I run this, and now I will get the output. Look at this. An array object is being created. You just created an object that is one-dimensional array object. All right. Then next is similarly you can create two-dimensional array as well, using what? Using nested list. put a list inside a list, and that too inside a array function from what numpy library. So np.array, and you have just entered list inside a list, and that's your 2D array, right? Similarly, multiple 2D arrays will be nothing but your 3D arrays, and so on. You can go on just creating multiple dimensional arrays. So I'll just run this cell for you, where you can see 2D array and 3D array being created. So this first output refers to the 2D array, and this output, second output, refers to three-dimensional array. All right. So moving forward, let's see. We earlier we talked about, when we talked about the difference. I said that its NumPy arrays are much more faster than Python lists. So just to demonstrate that, we have something called as time IT. All right, and with that we will see how, what is the time that is required when you do some operation with a given range. I have taken some, say, 10,000 numbers, and I'm trying to calculate squares of those numbers. So let's see which of the list, or sorry, which of them, like either the list does it in a speedy manner, or does array do it faster than list. So for that, I have created a list. I've assigned a range of 100, and then I'm with this time it, what I'm trying to do, I'm trying to calculate the time that is required for calculating squares of all those numbers. So they have applied a for loop. So basically they are using something called as list comprehension, and they have applied a for loop, and they are trying to calculate a square with this code, and we are trying to see how much time does this operation require. Now if you look at the output, you would see that we took around 2.77 milliseconds to calculate square of each number from 0 to 9999. All right, and when we do the same in array, all right, here you created an array object, pass the same range, and you are doing the very much same operation. You don't need a for loop here. It's a straightforward calculation, just squaring. It will when you write this, it will just square each and every element inside that array. Now let's see how much time does this take. And bang, you will see a lot of difference in the time. Here it was milliseconds, and here it is microseconds. So can you notice it's that efficient in terms of calculation? That's the reason numpy arrays are preferred over the list when such calculations come into play. All right, now let's see. This is something I think we have already seen, creating 2D arrays. Now there is one another way to create an array, arrays of ones and zeros. All right. So if you want to create an array which has only ones, so we have ones function in NumPy library which can be used, and we just need to mention what number of rows and number of columns. So 3 is number of rows here, and 4 is number of columns. And if you run this, you will see arrays of ones is created, and the whatever number we specify in rows and columns, it will take it here. If I want 4 by 4 or 5 by 4, it will do that way. So this is how it will just create arrays containing all ones. If you want arrays containing all zeros, your function will change to zeros. So as we have it for one, we have it for zeros as well. Then we also have a random function in NumPy. So the syntax, or the way we write, is np.random.random and 3 comma 4. All right, when we write this 3 comma 4, again is what, rows and columns. If you notice, the numbers that are generated here, okay, are do lie between what, 0 to 1. Okay, and there will be float numbers. So all the any random floating numbers would be generated from 0 to 1 using this random. So this is one another way. Now np.linspace. Now what will this function do? This, if you notice, we are giving a range like we used to give in for loop. Okay, we used to mention range. I mean, I hope you are aware and able to recall what range function did. We specify the starting point, we specify the ending point, and then we give the step size as well. Here, instead of step size, we are saying how many number of elements you want in that particular range, in the sense that we are starting at -5, we are ending at 5. All right, and how many number of elements you want in that, that is what we are mentioning here. This is not a step size. Instead, we are mentioning how many. So I want 10 elements between 5 and 5. So let's see what happens when we execute this. So when we execute this, we get 10 elements, and those are equidistant. In that 10 elements, the consecutive elements are equidistant from each other, in the sense the difference between 3 dot 888, this number 3 dot 8888889 and 5 will be same as the difference between these two numbers. These two will, the difference between these two, in the sense the difference between the consecutive numbers will be the same. Difference between these two, difference between these two, so they are what, they are linearly spaced, meaning the consecutive numbers are equidistant from each other. Just to prove my point, I will just mention, I will just show it to you. We will calculate the difference. I'll just calculate the difference. 5 dot minus 5.0 minus this number, right? So just to cross verify what we are trying to say when we talk about the lens space, okay? Um, then after that, what was this? Yeah, 3.889 minus 2.77778. Okay, that is what. You would see the difference between the consecutive elements is identical, and it takes care of the difference to be identical. Any number you mention here, if I mention 20, again it will do the same thing. Difference might change, it will not be constant always, okay, but it will be same, or you can say it will be identical between the consecutive elements of that particular array. So that's how you use lean space for creating what? Creating a linear spaced array. Then after that, there is something called as np dot identity. Now this is used to create an identity matrix. Now what is identity matrix? I'll just run this, then you will be able to recall. This is called as identity matrix. I did not mention rows and columns this time because in identity matrix, your rows and columns are same. You don't need to mention separately for rows and columns. That's why they just took one parameter. So if you mention 4, it will create 4 by 4 matrix. If you mention 5, it will create 5 by 5 matrix. And after creating that 5 by 5 matrix, it will create identity matrix, meaning the diagonal elements will always be what? Always be 1, and other elements are zeros, and that's something we call as identical matrix. So in this video, what we have covered is how to create arrays, and before coming to that point, we saw introduction to Numpy library. um, we also had a look that we had to have to install Numpy library. It doesn't come by default with Python. Then we had a look at what are the differences between Numpy arrays and Numpy list, and we also saw using the time it that we checked for list as well as arrays, and we could see there was a significant time in processing a particular array operation. After that, what we saw was how to create all those one-dimensional arrays, two-dimensional arrays, and what are different ways of creating those arrays. So I hope you have enjoyed this video, and we will see more of the concepts in coming videos. Okay, so that's the way we have started with our library Python libraries, and we will be looking into it in more details as we move on ahead. So thank you for watching, and see you in the next video. Thank you very much.